Hello ladies and gentlemen, and thank you for listening to Mr. Laxton's video on this Algebra II section 6.5a notes. Alright, so today we're looking at really how do I, my essential question today is how do I divide polynomials? All right, and we're going to divide polynomials today in two different ways. So if you have your red pen out, we're going to do it in two different ways. We're going to do it in long division, and then if we scroll down here, we're going to do it in synthetic division. All right, so we've seen synthetic substitution. Remember this big L that we did in the first semester? We've seen that. Now we're going to learn how to divide things using that same method. All right, so the first one here is long division. Couple different things here. Make sure to put zeros in for placeholders here as well. Just a couple things there. So if I have dividing this y to the fourth term by the y to the second, the y to the fourth term is what you're dividing into, and then the y to the second is the one that you're dividing by. Okay, so that's just, you have to put that outside the bracket here. So let's just jump into this and see how we do here. So the first one, it's dividing, it has, I'm taking this x to the third polynomial and dividing by this x minus 1. So if you guys remember, I know this has been a long time since you've done long division, but you take what you're dividing by, so that x minus 1, put it out in front, and then you have this big bracket, and then you have your x cubed minus x squared minus 2x plus 8 underneath there. Okay, and if you're doing long division, like if I had, let's say, 3 divided by 479, you'd take this 3, this first number, and you'd say, hey, how many times is that going to 4, my first one? And I know that that goes in there one time. Okay, so it's kind of the same deal here, but it's a little bit different with polynomials. So now I look at my x. How many times does that go into x cubed? So if I look at that, if I divide it out of there, I have an x squared amount of times. So I'm going to put my 1x squared above the x squared. It's kind of easy if you put it kind of in these columns with my x squared and my x's and then my numbers here. Okay? Awesome. So if I look at that, it goes in there x squared times. Now if I go back over this example over here, I would take my 1 times my 3 to give me 3, right? And then I'm going to subtract straight down. Same thing here. I take my x squared and I multiply it by this whole x minus 1. So I have x squared times x is x cubed. Keep it in that column for the x cubed. Now I have my x squared minus times negative 1. So I have minus 1x squared. Okay, so now if I subtract these guys straight down, this is where it becomes a little bit tricky. But if I subtract here, remember how that makes into adding the opposite? So I like to make this into adding the opposite. So x cubed plus x cubed, that goes away, that goes nothing. And then negative 1x cubed plus a positive 1x cubed is also 0x squared. Excuse me, the x squared. So now, I remember here, if I subtract straight down, I get 1, and then I bring down the 7. Okay, and it's going to be the same deal here as I go through. I'm going to bring down my next term, which is my negative 2x. All right, so now I look at how many times does x go into 0x squared. So I look at that, and I say, hey, it goes into there 0x times. Because if I multiply 0x by x, I get 0x squared minus 0x. Okay, this one's kind of nice as we go down through here because I get a couple zeros. If I subtract these guys straight down, obviously those guys are going to cancel out. I'm going to be left with negative 2x, and then I have to bring down this 8, so negative 2x plus 8. So now I have to ask myself, how many times does x go into negative 2x? And I'm going to say, hey, that goes in there negative 2 times. Because if I take negative 2 times x, I get negative 2x. And if I take negative 2 times negative 1, I get positive 2. So now, if I subtract these guys straight down, I like to add the opposite of both these guys. So this guys go away, so I get 0x, and then 8 plus a negative 2 is 6. All right, so if you remember here, this last number that we get, since I don't have any more terms over here, this is my remainder. All right, this is my remainder. All right, so now when I actually divide this into here, so my answer for this, folks, as I get an answer here, my answer is going to be x squared. I can kind of just cross out that 0x, it just goes away. Minus 2 plus, and you always put your remainder, that's what this says right here, the remainder always goes above the polynomial in which you divided by. So I'm going to have plus 6 over x minus 1. All right, so that is what I end up with if I divide this x cubed term by my x term. Awesome. So now let's look at a second one here. As I go with my example number 2, I'm going to say here I have x minus 5, and I'm going to divide that into 3x cubed minus 13x squared minus 11x and plus 6. Okay, so I have to ask myself here first, how many times does x go into 3x cubed? So I know that, hey, that can be 3x squared times. The way that I like to look at this too, if you get a little bit confused, is that you know that 3x squared times x gives me 3x cubed, and that's what you want to try to get, is what this number is here first. All right, so and now 3x squared times a negative 5 is a negative 15x squared. So if I go down through here and subtract these guys, I like to add the opposite. So negative 13x squared, because these guys go away, plus 15 is going to be 2x squared. All right, then I bring down this negative 11, so I have negative 11x. So now here I have to ask myself, how many times, I have a customer, and how many times does x go into 2x squared? And I can ask myself, hey, it goes into there 2x times. So I can multiply 2x times x, which gives me 2x squared. Multiply 2x times negative 5, I get negative 10x. So if I subtract these guys, add the opposite. So now negative 11x plus 10x give me negative 1x. Bring down the 6 plus 6. So to finish this guy off, how many times does x go into negative 1x? I'm going to say negative 1 times. So negative 1 times x gives me negative 1x, and negative 1 times negative 5 gives me a positive 5. So if I subtract these guys down again, I add the opposite. So 6 plus negative 5 is going to give me 1 for my remainder here. All right. So my answer, as I find my answer here, is going to be, let's put it in this color, it's going to be 3x squared plus 2x minus 1 plus 1 over x minus 5. So that is my answer. Always put that remainder over what you divided by. Alrighty, so that is long division. It's a little tricky at first, but I think once you do some examples, I think you'll catch on a little bit faster. Alright, so now synthetic division is really the same deal here. Okay, so your divisor always must be in this form, x minus k. You always take your k and put it outside. That's what we're going to divide it by. And remember that your k is always the opposite of what it looks. All right, always the opposite of what it looks. And the cool thing is here is that this last number that we get at the very end is going to be my remainder. And then these numbers that are on the bottom here are going to be my coefficients of my x's. All right, so let's go through here and see if we can find this first example. All right, so I have to divide this guy by my x plus 2. So that means here that my k is going to be negative 2. So I put that negative 2 out front. Now I have my L, and then I put my coefficients. So remember I have like 1x cubed, I have negative 3 for my x squared, I have negative 7 for my x, and I have 6 for my constant. So remember here that you don't have any zeros, but remember if you do, you got to put them in. So now let's go through and do the same process that we did before. Always bring down this first number. I get 1. I multiply in the diagonal, so this is negative 2. I add straight down, I get negative 5. I multiply in the diagonal, I get positive 10. Add straight down, I get positive 3, multiply, and I get negative 6, and I add straight down to get 0. So this 0 is my remainder, and I kind of like to put a little r there next to myself. And then this is how it works, ladies and gentlemen. When you divide this, the polynomial that you're left with after you divide is going to be your remainder, your constant, your x, and then your x squared. So it just grows as you move from right to left. So what you have left here is 1x squared minus 5x plus 3, plus in your remainder is 0 over x plus 2, but you don't really need that in your answer, so really technically just that, what I just boxed in, is your answer. All right, so to finish up this last one here, kind of the same deal, and my k here is the opposite of what it looks like, so it looks like -4, we're going to pull out a +4, so I get 4, I'm going to divide it by the same thing, so I still have that 1, -3, -7, and 6. Bring this 1 straight down, I got 1, multiply the diagonal, I got 4, you're good, and add straight down, I get 1 there again, so multiply, I got 4 times 1 is 4. If I add straight down, I get -3. Multiply in the diagonal, 4 times -3 is giving me -12. Add straight down, you get -6. So always remember here that that last number is your remainder, and then you move on from there. So I have my constant, my x, and then my x squared. If you had more terms, it would go to like your x cubed, your x to the 4th, x to the 5th, but in this case we don't. So here my answer is I divide that as 1x squared plus 1x minus 3. Then I have minus my remainder, which is 6 over x minus 4. All right, so as I divide x minus 4 divided by this whole thing right here, I get x squared plus 1x minus 3 with a remainder of 6. All right, so thank you for listening to Mr. Laxton's video on this 6.5a notes. Come find me if you have any questions.